this video, we're going to cover competitive balance. We're going to start by answering what is competitive balance, then we're going to discuss ways to measure competitive balance, and finally we're going to talk about various attempts by leagues to alter or set competitive balance. So what is competitive balance? Competitive balance is the degree of parity within a league. This is the notion that a team can win any given Sunday, as you might have heard. Sports economists often say the nature of the sports industry is such that competitors must be of approximately equal size if any are to be successful, and this seems to be a unique attribute of professional sports. In other businesses, we can have firms of different size. So the size, in quotes in this case, is not relative to the literal number of employees or market share, etc. But the size in this case, we can understand the success of a sports team as being analogous to the profitability or market share of a firm in what we might consider a normal industry, the type of industries that we often think about in the context of business. So sports are important because on one hand, the absolute quality of the play matters. So we do care to watch professional athletes play the games that we love and love to watch at the highest level. We can go watch basketball any given Saturday, just go down to the park and watch a pickup game of basketball. But that's not going to be the highest absolute quality of play. And typically, we like to see higher and higher levels of play. We might prefer college basketball to high school basketball. We might prefer professional basketball to college basketball because the quality of play and the things that athletes can do on the field or court become increasingly impressive and more worth watching. On the other hand, professional sports is also about the presentation and the spectacle of what's happening. So we want to remember that the parity, or sort of the relative play compared to each other, is something that matters, and it also matters within the context of the absolute quality of play. So that said, the absolute quality of play matters, the presentation and the spectacle matters, but the competitive balance really matters to keep fans interested, right? Fans are not typically as interested in a situation where even if the absolute quality of the play is very high, the play in the league is very lopsided. A classic example of this is when the Yankees ruined baseball from 1950 to 1958. During this time period, the Yankees win 8 out of 9 AL titles, and the Yankees' attendance falls by 31%, and the AL attendance, the American League attendance, falls by 20%. Now, perhaps we would say this is just due to some overall popularity lull for baseball or economic conditions, etc., except at the same time, the NL experiences a 22% growth in attendance. So the Yankees, by winning 8 out of 9 AL titles and 6 out of 9 World Series, they end up really cratering the popularity of baseball because competitive balance was very low during this time period, making the game less appealing to fans. Now, fans care because it's what makes the game interesting, and that's why owners care, is because fans care. They care because imbalance is typically bad for a league. They don't fundamentally necessarily care about that themselves. Now, maybe a few owners might, but as a general rule, owners want to win and they want to have a successful team. So what the leagues do is they come along and they promote the balance because teams cannot promote competitive balance. What we want is for teams to be attempting to win and for leagues to be attempting to make competitive balance as good as it can, sort of within reason while maintaining the integrity of the game. So every league has to confront the fundamental issue of the relative strengths between competitors. So in individual sports, we often see this take form in several particular ways. In combat sports, for example, we often see weight classes, that is, weight classes. In sports that are about speed over a particular distance, racing, track, swimming, we see qualifying times, and that helps seed the field. And so you will see a more interesting race based on the way that the race is then laid out. In tennis, we have seeding, we have rankings within it, and so we will get better matches as the tournament progresses. So we often don't see as many of these things in sort of the large scale team sports, but this is a really common thing in sport in general. So competitive balance sort of has this objective measure. So if we take the MLB, for example, we could think about one way what would be good competitive balance? Well, what if every team won once every 30 years? Well, we would say that's a pretty balanced league. All the teams are winning. No teams are winning, 8 out of 9 AL titles or 6 out of 9 World Series, as we discussed. We're not winning multiple titles in a row. We have lots of different teams winning championships, lots of different teams competing. Now, another way we might think about this is, maybe it's not just one per team, but we sort of weight the rate at which teams would win by what population is in their fan base. So teams with bigger fan bases might win more frequently. If we saw that, teams like the Yankees, based on being in New York City, they would win every 9 years. The Dodgers every 14, and the Brewers, who are in the smallest MLB market, would win one every 100 years. In reality, though, we see that we've got 27 titles for the Yankees in the last 100 years, which if they won every 9 years would be about 12 titles during that time period. So they're at more than double their rate there. And the Dodgers, who actually have 7 titles, would have won 8 during that time period. And the Brewers in the last 100 years haven't won, so they are sort of slightly off the pace there as well. So we see that what we actually observe in reality doesn't necessarily match up with what would be objective competitive balance. If leagues really were balanced, MLB were balanced. Now, one of the things that's not mentioned above is there are sort of some caveats to that, right? Yankees and Dodgers, they both share cities. So should the Yankees get 20 million population when we do this calculation, or should they split that with the Mets and it should be 10 million for them and 10 million for the Mets, right? So this is just sort of more of a thought experiment, but it's worth pointing out. And then, of course, where you're at in that timeline would obviously also really matter. Okay, so then what's the relationship between market size and wins? So if we're going to look at this competitive balance, we're going to weight it by population. That's related to the market size, right? What would the distribution of wins look like if we took this into account? Well, remember from our previous firm behavior, we have marginal revenue decreases, right? There's less return to increasing wins, but our marginal cost is constant for all the reasons that we discussed in the previous lecture. Again, we're going to go back to our marginal revenue is equal to our marginal cost is our profit maximizing choice. And we're just going to take a look at graphing marginal benefit and marginal cost against the number of wins. So we have our marginal cost is constant. We have our decreasing marginal revenue. What we're saying is the return, the return to a win for a professional team that's in a larger market will be larger than that in a smaller market. So what's the profit maximizing number of wins for the large team? It's here where the marginal cost is equal to the marginal revenue, whereas for a small team, we have a lower profit maximizing number of wins here. If, for example, we tried to make some amount of wins that was equal across everybody, we would see that this is not profit maximizing for either team, and that we would be sort of well beyond, the cost would be much too high for small market teams, and it would leave a many number of wins on the table for large market teams. So all of this is driven by an important idea, which is that there are diminishing returns in this case, and the diminishing returns means even for large market teams, it is not always the case that they must have another win, always winning and trying to win more, right? Large markets have more incentive to win, but they still only acquire talent up to a point because of these diminishing returns, right? consider if you have a star player at a position, right? If you're talking about the 2000s era Patriots, they were not interested in acquiring quarterbacks because they had Tom Brady. Well, as you're a large market team, you're going to have more willingness to pay because you have this higher return to each win than does a small market team. But that still doesn't mean you have an unlimited desire to win. You won't get all of the players. Now we can sort of think of some classic eras. 90s Yankees would be a good example, probably 90s Cowboys as well, where we see really lopsided rosters where these really large market, high profile teams are signing up lots of free agents and constructing really excellent teams because their marginal benefit from acquiring those players is very high. But it's not unlimited, and that's what we're meaning by diminishing returns in this case. So what then has the history of competitive balance looked like? Well, in the MLB, we saw, of course, before the 1950s, but there's also the 1920s Yankees. And then you've got the Yankees in the late 40s and early 50s who win five straight titles between 49 and 53. In the NBA, there's a similar case with the Celtics who win 9 titles between 59 and 69. In the NHL, it was Montreal winning 10 titles between 65 and 79. But in the NFL, no team has more than 2 titles in a row. So there's sort of maybe a much better history of competitive balance there in the NFL, whereas these other leagues have some stretches where there's been a truly dominant team for a long period of time. MLB with several instances of it, as we've discussed. So let's turn now to measuring competitive balance. There are basically 2 categories that we want to be thinking about when we're measuring competitive balance. One is within season balance, and the other is between season balance. Within season balance measures the deviation, the dispersion of wins within a given season, right? So we use a statistic called standard deviation, which is just the distance from the sample mean, which of course in a sports league must be 500 because for every win that one team gets, another team gets a loss. So the ideal standard deviation then is this 500 divided by the square root of the number of games played, which is to say the more games that are played, the closer we can have a standard deviation to this ideal number. So let's imagine just for a moment, right? If you played an infinite number of games, that would drive our standard deviation of that particular league down to 0. If you have a very low, right? So if you have just one game, then of course the best we can do is 0.5. So we want to think about standard deviation in that way. Let's use a quick couple of graphical examples. So if you sort of highlight here where all of our games denoted by the pink dashes here, they're very tightly dispersed compared to the yellow dashes, which are very widely dispersed. We'll have a much higher standard deviation for the yellow games than we do for the pink games. They're not as far from the mean, where the yellow dashes are much, even though there's few sort of on the line, right? We can see a much wider dispersion of games, and that standard deviation is a way to think about that. Okay, let's separate these two into 2 separate cases here. So in this situation, we have much further distances. The standard deviation will be much higher than here, where we have a bunch of very small deviations from the sample mean, right? So what we want to think about is each of these dots is like an individual team's record for a year, right? And so if we're looking at a team where there's a season where there's a bunch of teams all very close, just a little bit above, a little bit below 500, we're going to have a situation more like this, which is why I drew this line flat. The slope line is kind of like the classic example that we might see in other situations, but in our case it would be a flat line, right? And we can measure that dispersion from all the different teams relative to the sample mean. So I just want you to think about this. If you have one league in a particular season, and there's some team winning only 25% of its games and another team winning 75% of its games, and all distributed in between will have these sort of very wide distances from the mean. If you have another year in that same league and the losingest team is winning 40% of their games and the winningest team is winning 60% of the games, they're much closer. Each and every team is much closer to that 50%. And we can measure that with what we call standard deviation. And that will allow us to then compare. So let's look at these examples of the dispersion of winning percentages. So what we do, right, is we take that actual number, right? So that's this number. These are standard deviations right here. And then we can't compare MLB to NFL because MLB literally has 10 times as many games as the NFL. There's 162. There's 162 games versus 16 games for the NFL. So we need this ideal number. So that is this calculation here. I'm going to say the MLB, if it had like the ideal dispersion of winning percentages, we would come up with this number. So now we can divide 0.069 by 0.039, and we can get this all-important ratio here. And so we can see that if we compare, even though the NFL had a higher dispersion, it has fewer games, so it's ideal, the number it can realistically get to is much, much lower. Notice that this is 1/8, right? So there's no sort of surprise there. And when we compare those, we see that the NFL has a much lower ratio than the MLB. The most imbalanced league is the NBA by actually quite a wide margin. And the English Premier League is the most balanced, with the NHL close behind, and then sort of the NFL and the MLB here in the middle. Remember, this is within season dispersion of winning percentages. If we fast forward to 2019, we see that the MLB is less balanced. The NFL is more balanced than it was before. The NHL is more imbalanced. The NBA is roughly the same. And the English Premier League is even less balanced than it was. These ideal numbers, obviously, are going to stay the same because that number of games stayed the same. Now we can come up with new ratios. So what happened? There's a huge change in the MLB. It has become even more imbalanced. NFL roughly the same. NHL switched from being on the low end to being much, much higher. NBA even more imbalanced than it was before. I'm sorry. There's still highly imbalanced. The most imbalanced league is the NBA. And we could sort of speculate as to why that is. If you look at the number of players that are on the field in each of these cases, the NBA has the fewest, which means it is going to have much more concentrated returns to a particular player having talent. 1 or 2 star players will really tip the balance in a particular league. And then the English Premier League, quite a bit more imbalanced. So we see a trend. Basically, all of them except the NFL got more imbalanced. The NFL went from being sort of middle of the pack to being the most balanced by quite a long shot. Now, let's turn our attention to between season variation. So in this case, competitive balance implies a team could move up in the standings year to year, or they could make the playoffs sort of year to year, right? So there's the changes between. So it's not that, at any moment in a season we could make the playoffs. Eventually you're going to be eliminated from playoff contention if you don't make the playoffs. This is what we call turnover or team-specific variation. Year to year, how do your odds of being a successful team by moving up in the standings or making the playoffs or winning a title change? Unfortunately, this doesn't really have an objective standard of comparison because it's not obvious. What if you're a good team every year, wild card making the playoffs, or what if you win first some years and then your last other years? It's sort of that idea of like win percentages over time versus caring about where you finish in the rankings. If I'm in a not very competitive division and my team wins, but they only have 55% win percentage, which would be good but not great for an MLB team. But I win my division, I get a high ranking, but not necessarily high win percentage. So it's actually somewhat unclear. I think probably in most cases, and think of this yourself while you're listening to this. Which of these two would you rather have? A team that's always competitive, always coming in second, always making the playoffs, sort of a good team to watch all the time, or would you occasionally rather be first and then last in other years? I think the world that we probably live in now, teams care about winning championships and winning something and not necessarily just being competitive. This highlights the idea that there's no clear standard for comparison like we had with in-season variation. So to measure between season variation, we're going to be largely focused on the frequency of championships. And a way to do this is to measure competitive balance by successive champions. So if one team always wins the title, it doesn't matter how balanced regular season play is, that league is fundamentally imbalanced, right? So if one team wins the championship year in, year out, but they beat a different team every time in the title game, that's just obviously imbalanced. On the other hand, if a new team always wins, even if regular season play is super imbalanced, that league is by definition quite balanced. So frequency of championships is an important metric for measuring between season variation in competitive balance. So let's take a look at that. The way that we do this is with what we call the Herfindahl-Hirschman Index. This is an industry concentration measure. So what it's saying is, if we look at all the competitors in a given market, how much of the market share do they have? And the higher the concentration, the more one firm has of that market share. Say it's a monopoly, they would have the whole market. That would be a completely concentrated index. We would have a measure of 1. So the way that that's measured is just the sum of the market share for a particular industry divided by the totality of the market share squared. And so we write that out as follows, which is the share, so in our case championships, over the time period in question squared. So Ni is the number of wins for team I. T is the time period measured in years. And of course, this capital N that I'm talking about here is just the total number of teams. Okay, so the minimum, the least concentration we can have in HHI depends on whether there are more years or more teams in the sample that we care about, because we have to measure Hirschman-Herfindahl index over a given time period. So if there's more years than teams, then obviously the lowest we could have is 1 per team. That is, every team wins during that time period. So if we're thinking about the NFL and there are 32 teams and we're looking at a 40-year span, then the lowest it could be is that every team has 1 win and some teams have 2 wins given that time period. So if we measured exactly 32 years, that would give us 1 over N. Now, if there are more teams than years, say we're looking at college football, there's about 120 teams, and we measure a 10-year span, then the most that we can do is just have a new team every year for those 10 years. The lowest would be 1 over T. So let's just very quickly sort of write this out as an example, right? So if we look at the NFL, right, and we're looking at 32 years, or really let's make this number 32 years, the lowest it could be is 1 over 32, because that's the number of teams. If we're looking at a situation where we're looking at a new team every year, and we look at, say, college football, 122 teams over 10 years, then the lowest that could be is just a new team every year. That kind of highlights what the minimum number could be. Okay, so the max, of course, is just 1, and that's where one team wins all the championships. Okay, so let's work out a little example, and let's take the BCS era of college football. And here we have 16 years total of play. During this, Alabama won 3, Florida won 2, Florida State won 2, LSU won 2, and Auburn, Miami, Ohio State, Oklahoma, Tennessee, Texas, and USC all won 1 during that time period. So how do we go about calculating this HHI? Remember what I said? Let's go back to the page very briefly, right? It's the number of wins over the time period. So Alabama won 3. There were 16 years. Florida 1-2, Florida State 1-2, LSU 1-2, and then we have Auburn, Miami, Ohio State, Oklahoma, Tennessee, Texas, and USC all won 1. Every other team won 0. So we can just sum up all of those. Of course, right, this will just fall out to be 0. We then do the math on this, right, which is 16 times 16, and then 3 times 3, 2 times 2, and so on until we get this number here. That sums up to be 28 over 256, and that is 0.11 HHI. So the minimum in this case, right, would be what? One new team every year, because there are more teams, about 120 over a 16-year period. So if we had a new team every single year, then we would have 0.062 concentration. Now, of course, what can we do? We can create the ratio. What if we take this 0.1 compared to that minimum ideal, and we can get this ratio. Now, what's important about this, though, of course, is that this is a little bit of a small sample size, and so we want to sort of limit the extrapolations that we do logically from this. Another way that we can measure competitive balance is through what we call a Lorenz curve, and this is really useful for sort of illustrating things. What does a Lorenz curve do? This is an idea from labor economics that demonstrates inequality. And the fundamental question that a Lorenz curve is trying to answer is, how evenly is a resource or characteristic distributed through a population? So what we have is a 45-degree angle and a line. So it's just one-to-one between the representation of the resource or the characteristic and the share of it in the population. So if our line just falls across this line, that means everybody has the exact equal share of that, right? If we have a line that falls off the curve a little bit, then we can see how this might work out, right? So 5% of the population has 2.5% of the characteristic. That line falls like so. If 50%, this is cumulative, has 10% of it, and so on, eventually, right, here we're demonstrating that this is below. So if 50% of the population only has 10%, the other 50% must have 90% of that characteristic. So that's why the line must always converge back to this line. That's why they're always going to end up here. Now, this blue curve that I'm highlighting here is even more unequal distribution. The 5th percentile, as you can see here, has almost none, has 0.00 something percent. The 50th percentile has only 2.5, right, where we said that it was 5% of the population had the bottom 2.5% of, let's say in this case, wins. And in this case, the 50th percentile, which means the top 50%, has the remaining 97.5% of the wins in this case. So the further the curve moves away from the 1-to-1 ratio, the more unequal the distribution of it is. Okay, so that can be a little bit confusing, so let's use an example. So here's a graph of the distribution, performance and earnings from Scully's paper in the 2002 Journal of Sports Economics. And this shows the winnings by professional golfers against the fraction of golfers that won that much. So this is just a percentage, right? So what is this? Somewhere around 70% of golfers win less than $500,000 in total earnings. And we see here, maybe that's 15 to 17% of golfers win in this range of $1 million. And then just a handful, 2, 3, 4, 5% win 2.5. And then a handful of golfers win these large amounts. There's just a few. And then, of course, these golfers over here would be the ones we can name. This is probably Tiger Woods and some other very famous golfers that have career winnings up here around $10 million in total prize monies. What does that look like when we graph it as a Lorenz curve? Well, this is just our year 2000 earnings, so not total career earnings. So this is just one season's worth of earnings. If we graph that out, we see that there's quite a fall off. So let's just take a look. The 50th percentile is here. So if we graph that over here, it's somewhere around 50th percentile. In fact, let's just make this a line so that we can actually see it. So there's the 50th percentile. something like 10%, right? So the bottom half of golfers earn 10%, and the top half of golfers are winning 90% of the earnings. Let's see, where does the breakover happen if we come look at the 50th percentile of earnings? This is happening at like 0.85 or something like that, right? If we come up here, what is like the 90th percentile in earnings? We get, that's a little low, we get something like the 95th percentile of golfer, and so on. So you can kind of see this helps us understand how the Lorenz curve illustrates for us what the inequality of winnings is. So basically, that is to say, you really have to be a tremendous golfer. Your scoring average, right? So remember, this is par, right? So the average is somewhere around 71. So right, so golfers are playing slightly better than scratch golf, which if that doesn't sound impressive to you, remember that the courses that PGA players are playing are much tougher than your average course, right? And so there's a really disproportionate, this is a normal distribution, right? There's really disproportionate earnings for being players that score very excellent scores, very low scores.